Given a whole number, we want to add up its digits. For 7,789, that is 7 plus 7 plus 8 plus 9, which is 31. We will do it recursively by peeling one digit off the end each time and adding it to the sum of the digits that remain. Two little pieces of number math do the work. The last digit is n modulo 10, the remainder after dividing by 10. And integer division by 10 chops that last digit off. So the sum of all the digits is the last digit plus the sum of the digits of what is left. We hand the shorter number back to the function and add its last digit on top. Each call makes the number smaller by one digit until it becomes 0, where the sum is 0. That is our base case, and because a digit is removed every time, we are sure to reach it. If n is 0, there are no digits left to add, so we return 0. That anchors the recursion. Otherwise, we take the last digit, n modulo 10, and add it to the sum of the digits of n divided by 10, which is the number with its last digit removed. Let's write it and add up the digits of a few numbers. The base case. When the number reaches 0, there are no digits left, so the sum is 0. The recursive step. Add the last digit to the sum of the digits of the shortened number. Now, let's test it and hit run. There we go. 7789 sums to 31, 5 sums to 5, and 100 sums to 1. Each call peels off one digit and adds it to the rest. The flow is short. If n is 0, we return 0. Otherwise, we return the last digit, n modulo 10, plus the sum of the digits of n divided by 10, and we keep shrinking the number until it hits 0. Each call removes one digit, so the number of calls equals the number of digits. A number with d digits takes d calls, and the digit count grows like the logarithm of the number, so the time is order log n. The space is order log n2 for the recursion stack. 3 reminders. First, modulo 10 gives you the last digit while integer division by 10 removes it, and you need both together. Second, the base case at 0 returning 0 also quietly handles the number 0 itself, whose digit sum is 0. And third, for a negative number, take its absolute value first, since the digits are the same either way.